Hi everyone. So after learning about the use case diagram, in 10 minutes, we are learning from the mistakes that I maybe found in some submissions. So now we are going to go through the correction of practice 3, and we are going to do it together, use case diagram, step by step. Okay, so in practice 3, what we have, so it was kind of a use case, and I'm going to share my screen and show you this use case. So mainly in practice 3, I'm sharing the correction file with you. And this is what we are going to build during this video, but this is the use case or the system that we are going to study in this practice. So I previously explained it. This is the grain elevator system and GES, and more details about this system and how it works are available in that links. However, here there is A, B, C, D, E, and so on, few paragraphs that describe the functioning of this system. Okay, so how to build your use case is that you're going to read very well the specification, the description of your system, and from each paragraph mainly you will get some information. So this is what we will do. Okay, so let me again come back to my slides and share with you. Okay, so this is our grain elevator system, and we go and read the description. So the grain elevator system is a program for tracking the grain, and this I'm copying, kind of copy paste from the description to show you how to read, by the way, because unified modeling language, when you have specification, it's mainly about reading and understanding, interpreting whatever you read. This is why mainly the submissions must be very similar. Maybe you can change some names, you add some few details, you add extra use cases, but mainly when I go through student submissions, most of them must be the same, almost. Okay, I will explain how. Because we are reading the same support. We're using the same I would say material. Okay, so the grain elevator system is a program for tracking the grain stored in a grain elevator as it arrives in trucks from farms and is shipped out in trains from the elevator. In paragraph A, we have that harvest grain is tracked from farms to a central storage elevator where it is placed in silos. The grain is eventually moved from the silos to railroad cars that take it to processing plants. The elevator relies on a software system to track the grain. So in this first paragraph, we are introducing our system. So here you have the definition of your system boundaries, and you can capture the overall purpose or idea of your use cases. So how to represent that? We draw first thing our system boundaries and the name of our system. Here I'm just mentioning the abbreviation for grain elevator system. Okay, so next we have in this paragraph E some information. It says that grain stored in the silo must be kept dry. Therefore, the humidity and temperature of each silo are closely monitored. Humidity and temperature sensors in each silo send data to the system periodically. If the temperature or humidity of a silo exceeds normal levels, the humidity and temperature sensors will send an alert to the system as well as to an external grain dryer until its temperature and humidity levels are brought back to normal. The silo cannot accept any more gain. So from this paragraph, there is something that we can, the overall idea. So this paragraph talks about some sensors, okay? So it helps us, this paragraph, to identify the sensor actor. So these sensors are actors. And these actors are not human, they are system. And I mentioned that we can put them in a rectangle, but still we can use a stick man. I have no problem with that. But the most important that I see on the right side or the left side of your system, one actor named sensor, mention the name under the stick man or so. And what does this sensor do? So it updates the silo status. So there is some use case that we can call update status that we are extracting from this paragraph. How to represent this now? We have our system boundaries. I'm putting this actor, its name sensor, and this is what use case he do. He update the silo status simply. Next, I keep reading. For accounting purposes, the system maintains a transaction log that records for each shipment in or out of the elevator all the information about the shipment, namely the quantity, type, and grade of gain, the time and date, the elevator manager, the type of shipment, whether it's arrival or departure, the truck or rail car identifier, the driver or conductor, and the seller or buyer. So from this paragraph mainly, what we can learn. So this paragraph introduces the need for reporting or logging feature. So it could be represented by request report use case. So here we understand that this system have something that can track whatever report. So we don't know still information about who is the actor doing this, but at least this system has some report. We can request this report and get it, by the way, okay? So we just draw this use case. No need to mention the actor because still we don't know. We keep reading things. So when a truck arrives at the elevator with a load grain, the elevator manager, now you see someone is there. There is someone who is called the elevator manager. So this is the actor who does that mainly. The elevator manager informs the system of the type of the grain, its grade, and its quantity. The system must find one or more silos to store the grain and tell the elevator manager which silos it has chosen and how much grain goes in each one. So from this paragraph, first of all, we can define the elevator manager actor, and this elevator manager actor is the one mainly who have access to the system and in particular to the report maybe, okay? So we keep reading. And so when a truck arrives at the elevator with a load of grain, the elevator manager informs the system of the type of grain, its grade, and its quantity. The system must find one or more silos to store in the grain and tell the elevator manager which silo it has chosen and how much grain goes in each one, okay? So from this paragraph, in addition to the elevator manager as an actor, we can have information probably about another functionality that he can do. So this elevator manager also can enter an arrival shipment, and it can allocate silo, which are use cases that we will discuss. So how can we connect these use cases? It can be connected via an include because it mentions that it's a must, okay, if you have an arrival shipment, okay, so the system must find some silo. It must allocate. It's not a joke. It's an obligation. So it's not an option to say that it's an extend. So it's an obligation. This is why we need to use an include between these two use cases, okay? Next, the elevator manager may accept or overrule the system's choice of silo for an arriving load. So it's not always that he's going to reject, and it's not always that he's going to accept. So here we are probably thinking about something which is optional. The elevator manager, from a given use case, can do or cannot do that. So here, there is the optional manually allocate silo use case. Extend the allocate silo through the extension point, which is a manual overrule. Okay, so here I will come back to this use case, but it has what we call extension point. For me, it's okay if a student is making them two different use cases. Okay, I know that we didn't cover this, but also during the correction of the practices, I want to teach you things. Okay, it's not obligatory that you will have this in the exam or in the practice, but I want to teach you as much as I can. So we have the elevator manager. He enter an arrival shipment. Obligatory, this arrival shipment, we must some silo is allocated for it. Okay, but if he's going like to manually allocate some silo, it is possible that he like do kind of a manual overdue. So this is known as an extension point. But what is an extension point? So mainly it's like hooks or injection point of the main use case. So think of, for example, the allocation like silo as main procedure. Inside of it, there is a step called manual overrule, where the manager made, like, for example, intervenes. That's your extension point, okay? The meaning, kind of, the split overall. So in this case, the division of the allocate silo, like silo use case, visually, it communicates that this use case has one or more extension, okay, points. And the extension points, here we have one, which is the manual overrule, okay? So you still like can go to another use case, plug in kind of an additional behavior related to the same use case. So this kind of representation can help your user like mainly quickly see whether an extension can occur or not. Now, in this case, an extension that is called manual overrule can occur. And in this case, it's like which use case like triggers to this one. So it is the manually allocate silo, which is this one, okay? We have the relationships now, include and extend. So for the include, if you have enter like arrival shipment, okay, this use case, so it includes allocate silo. In this case, it means like every time a shipment is entered, the system must allocate some silo for that. So that's a required step. However, for the second part here, where we have the extend, we have the manually allocate silo, extends the extension point, what we have here, the manual overrule, okay? So manually allocate silo extends like the manual overrule extension point, and this happens only if the manager decides like to override the automatic allocation. He can decide that or he cannot. So this is optional. So in this case, we have one include and one extend in our diagram. Now we keep reading. The elevator manager must inform the system how much grain is actually deposited in each silo and enter data about the truck, the driver, and the seller. The system should acknowledge receipt of the data. And from this paragraph, we can probably confirm that first or second use case that we mentioned, which is the enter arrival shipment and manually allocate silo that are performed by the elevator manager. Like this, just we are making sure that these two are there and it clarifying more our understanding. The last like paragraph I here, it also as a train loaded, the elevator manager must tell the system how much grain has been removed from each silo, and the rail cars loaded, the conductor and the buyer. Here we have the system should acknowledge receipt of this data. This paragraph gives you information about the enter departure shipment use case. So this one, it's like an additional use case that we are adding, and it is performed by the elevator manager. Okay, so the last one also, it just confirms about the request report. So we have in this paragraph, upper request from the elevator manager, the system must produce a complete report of the state of the elevator. So we have just confirmation of this use case. So mainly this is the use case model. It's simple, it's clear, it's like extracted from the what we say, the description. Okay, so I'm not bringing anything like from my own brain or imagination. No, everything is there. You just need to make sure which is a use case, which is a connection with another use case, which is an actor, and what each actor does, and so on. Okay, I think that's all for the this practice. Probably for questions B and C, I can show you that it's already detailed in the sorry questions. Okay, questions B and C, which are mainly about the dictionary and the use case description. So we have that detailed in that answer file I'm going to share with you. So I think it's clear, and you can go through that. Okay. Otherwise, let's go quickly through practice 4. So in practice 4, mainly I'm going to share with you detailed correction of your sequence diagram, use case first. So this is an example of the use case diagram. How we are doing this use case diagram mainly is the same way of thinking that I was showing you now, my different actors and what use cases, if there is any include or extend between the use cases. And next, so there are like course registration system. You can find more detailed elements about this in these diagrams. And next we have our class diagram. So you have your classes, the relationships between these classes, and always make sure that you read well and then you translate that into diagrams, okay? And the multiplicity and so on. You can come back to the video covering the class diagram, and also for the sequence diagram. These are an element of your system, and this is the user, this is how it interacts. We can find some alt, like this is something that is discussing different alternatives, like different cases and scenarios and so on. Okay, so this one is detailed. You can just refer to that, and feel free to ask me if you have any questions. And by sharing these files, sharing these recordings, I am sure that you guys are now ready for the midterm exam. So keep working hard, and I wish you the best of luck. Okay, good luck in your midterm.